right? I think this was where we were at last time looking at this. No, not this one. Yeah, something like that. Let's see. Whoops. How did I close? There we go. Oh yeah, I got some movement. I was just tinkering with this. Can't remember why I was doing that. This is animation going on in a canvas, and I was going to demonstrate that, show you how to do that, and then also we were in here with this game here, I think. This is not working. And yep. So what do we want to do? Do we want to keep looking at canvas and see how to do, say, like an animation like this, or go back to CSS, do some more CSS work? What do people want to do? Anybody want to throw out? No? Nobody? All right, let me just go forward here then. I think I was working in this folder here. Can't remember. Yeah, I think it was in this folder here. So we got an error message here, line 34, you can see right there. A box is not a constructor. Okay, let's take a look at that. Line 34, it's right there. So we're using the new operator and a dot box. Remember last time I was talking about using a as a the sole global variable, and then putting all the application variables under that. I chose the variable name a because it's short, so keep the lines short, and also it's an abbreviation for application, so it's the application code inside a. You could think of it as a namespace. So in this namespace, or in this object, there's another object, which is a constructor function. Well, all functions can be used as constructors. And in other words, all functions can be passed to this new operator to create a new object. And so here I have the name of the function is box. This is to create a box. This would be the location in the canvas, XY. This is the width and the height of the box and the color, okay. But it's saying here that a.box is not a constructor. And there's another error message there as well. Like this is in line 25, this is in line 34. I'm going to go back to line 25 and see what's there. So push, I cannot read property push of undefined. So a.objs is undefined. I think I must have been renaming things. I didn't finish it. Yeah, so we got a underscore canvas. I talked about this last time, that these IDs actually result, when you set an ID in the HTML file, it results in a name, an identifier going into the global namespace. So I decided on this convention for myself to use a underscore as a prefix to all these IDs, because it resembled my application object name A. So it'd be a.objs. This would be similar, just sort of a similarity there, a underscore canvas. All right, so here define the canvas. So we load this script a.js. I think probably that's what's going on. Oh, there's a.js right there. Oh, we were playing around with this. And there we go. So the box is in here. Here's the function box. A box is a function, so it can be used with a new operator to create a new object. And here's the argument list, X, Y, W, H, and color. And so when this constructor function runs, when this function runs as a constructor, the keyword this is used is a reference to the object that's being constructed. So we populate the object with attributes. So inside the constructor function, we go to this dot x, this dot y, and so on. So we're creating 5 attributes in the constructor function, x, y, w, h, and color. And so this dot x, we're setting that to the x that's being passed in as an argument. But actually, you could call this constructor, you could go new box, open parenthesis, close parenthesis, without passing in any arguments. And if that's the case, then x would be undefined. And I'm going to allow that in my code. I'm going to allow my code to use a box constructor without any arguments. So in that case, when x is undefined, that this x here, it's in the left-hand side of this logical OR operator. And so JavaScript will will look at this undefined and treat it as a false value when it appears inside of a logical, when it's used with a logical operator. And so x, if x is undefined, then it's considered false. And if the left-hand side of the OR operator is false, the system doesn't know how to evaluate. It doesn't know whether the result of the OR operation is true or false, so it has to evaluate the right-hand side of the operator. So in this case, just a constant 0. And it actually just ignores. I don't think it doesn't even concern itself with whether the right-hand side is true or false. If the left-hand side evaluates to false, it evaluates the right-hand side and assigns it and uses it as the value of the expression. So this expression evaluates to 0 when x is undefined, and that's what's assigned to x here. So this is a common pattern that you see in scripting languages, not just JavaScript, but other ones. This is called short-circuiting. So if x were to be a number that doesn't evaluate to false, so anything other than 0, if x is 0, then the system would, then the left-hand side would be considered false, and then 0 would be taken from the right-hand side and assigned to x. So that's going to work fine. And here, actually, if the width is 0, this doesn't work, actually. If the width is 0, look at this. I just realized there's an error, a logical problem with this code. If I pass in 0 for the width, then the left-hand side evaluates to false, and 100 will be assigned to w. You see the problem? So this actually doesn't work. If I want to allow values of 0 for w. I just thought of that. I never realized. I never thought about that before. It doesn't make much sense to create a box with a zero width or a zero height, but that's how that would work out. So I would get an error if I wanted to allow zero width or zero height to work, because this constructor would set the width and height to 150 and 50 in that case. So just sitting here now, doing this presentation, I realized that there's a problem with those two lines. There's an issue there. Anyway, let's go back to the issue we were looking at. We can look at that. Let's go back to that later. So a.box is not a constructor. So what we're going to have to debug this thing. Now, first of all, we're inside this anonymous function that we're going to run. So the scope of this box function is local to this anonymous function. Also, this is not just, even if it was global, we would still get an error here because it's a.box. As I go down to the bottom of the file, I think I have in there we go, a.box equals box. So here I leave, this is one style that I've come across in the years I've been looking at this stuff. Especially in Node, you see this in Node.js modules in general. And I might need to talk about modules at some point, although I don't use them when I do web development, but I mean client-side development. I use them in server-side development using Node.js. Modules are very important. But modules are increasingly being used on client side as well. And there's different approaches to that. All right, so I take the locally defined box function, assign it to an attribute name box that's part of the global name A. So why is this not failing? I see A is not defined anywhere. That's the thing. Where is A defined? Is A in here? A is not. Oh, here is A. Right. Oh, we were practicing with this business here. We call that sync, right? Sync. So this gets loaded first. And when this runs, A is not yet defined. If I made this asynchronous, that means that when the browser hits this point, I'm telling it to, well, I'm not. When the browser hits this line, it'll start retrieving, or it can start retrieving a.js, but it won't evaluate it yet. It won't run it. It'll continue executing and evaluating the rest of the lines in the HTML file. When it gets to the bottom and the document is considered loaded, then it will evaluate a.js. So this is actually going to work, I think. There we go. So now we got the game is running again. And one of the reasons to do it like this is maybe the page will load faster, a tiny bit faster. I'm going to take that out, and I'm going to make this run synchronously. So this will run first, and then we'll continue on to here. So I'll need to define the application object in here. So we don't want this to run as a result of the load event. There's many different ways of doing it. There we go. So we hit a box, it stops for a second and goes away. All right, I'm going to get rid of these debugging statements. All right. So a.js, define this globally scoped application object. And then I could, instead of using that get element by ID function on a document object, that's what I was doing before, and now I'm using this new approach. That we can, a underscore canvas is the globally scoped identifier that comes from the ID value. And we call it get context. There's two different contexts that you can get that I know about. One is 2D and the other one is WebGL. There may be others. And then there's some options. False, alpha false means don't. I'm not clear about the effects of this actually. It has to do with whether you want to support an alpha channel in the canvas. We can experiment with that to see the results of that. We could dig into that and find that out. The benefit of turning this off is that I've read is that that if you don't have to handle alpha values, then the system can execute the code faster. So this could be some speed gain on that. And but I haven't noticed that, and I don't even know exactly how this is supposed to work. So since alpha is false. I think I'm going to leave that out for now, because I don't really understand that, to tell you the truth. If we want to understand it, we've got to do some experiments. And I don't know if it's worth our time right now. All right, so here we have a constructor function, text. It takes a string, a coordinate value in the canvas, a color, and a font. And I'm using the same procedure that I used before. Here I don't have the issue. Right, if x is 0 or y is 0, I'm setting it to 0 on the right hand side, so that's okay. If color, there's no color value I can think of that evaluates the false. Same thing for font, so we don't have to worry about that. And the text, this is interesting. What about the text? Look at this. What happens when the text is false? Is that considered false inside of this OR condition? Well, let's see. We can evaluate it down here inside the console window, actually. Watch this. So if we go, if I do this, watch it. If I go 1 or a 2, it's going to print 1. And if I say 0 or 2, it's going to print 2. The 0 is interpreted as false. That's the same as doing false or 2. So it's the same thing. But what happens if we use quote false or 2? Oh, then the string false is not evaluated as false, and so we're safe. We're safe. This is safe. But look down here at this issue, right? This.w is w or 100. Now watch what happens with this. Let me clear this. Here we go. W or 100. So if we had, if we had 3 or 100, we're going to get 3. 0, of course, the way one is false or undefined. This is the thing that I'm considering. The case that I was focused on was when the left-hand side evaluates undefined. But what happens when the left-hand side is a valid number, like a passing in 0 for the width? Although I can't think of a reason to do that, but if I did, look at the result. I get 100. So there's a bug here. If I want to allow the case for w equaling 100, so this expression wouldn't work. So let's fix that. And sort of messes up the nice pattern I've got here, but just for the sake of rigor, let's redo this. We could do it something like this. We could use a ternary expression or just a simple if condition. So we could do if I've read that the formally correct way to do that is like this. Type of W, if type of W is undefined as a string, then W equals 100. Else W equals, sorry, it should be this dot W. Else W equals 100. The type of H is undefined. This dot H is 100, else H, sorry, this dot, what the heck am I doing? I'm like asleep up here. Sorry about that. Totally asleep. There we go. It's not as pretty, but that'll let us pass in 0 for W and have this dot W set to 0. That's interesting that I've been doing that for so long and I never thought about this case. And bugs can creep in so easily into your code, even after years of coding, and it's things that you don't think about until later. And I've heard it said, and I do believe it's true, that large systems, like say operating systems like Windows, right, or OS 10, they're riddled with bugs. I mean, this kind of a bug would be easy to have all over the place. All kinds of bugs that the mature programmers are still producing. So it's just the nature of the business. Another way to do this would be like this. Maybe this is a shorter version. So if, how could we do? We could do it like this. We could say if H is undefined, then this dot H is 100, else this dot H is H. It's a little shorter. Which one do you like? This one? You don't use the quotes here. Now, undefined is actually an object, just like null. Null is also an object. It's a data type and an object. Undefined is null is a data type that has only one value, null. It's like Boolean is a data type with two values, true and false. Right? Integer is a data type with all the integer values. But null is a data type that only has one possible value, null. And I believe undefined is undefined a data type in JavaScript. This is how they think of it. This is how the language people talk about it. In JavaScript, there are 6 primitive data types: string, right? Number, Boolean, null, undefined, and symbol. I didn't know symbol was a symbol. But it's a new in ECMAScript. This is another name for JavaScript. So undefined is a data type. Null is a data type. It's a primitive data type. Once again, this null, the data type null has only one possible value in it, which is null. Same for undefined. The only possible value in the undefined data type is undefined. But Boolean, the possible values in the Boolean data type are 2, true and false. See, interesting. Let's take a look at that. Yeah, I'm not going to do this. Oh, look at this. The global undefined property represents the primitive value undefined. It is one of JavaScript's primitive types. So here they're using this expression here. They're comparing t to the data type to the value undefined. So this works. This expression works. I don't know why this is frequently promoted as the right way to do it. I don't know why I've never seen a reason to do it like this. I mean, this is longer. And once again, I don't know the reason for that. So I'm not going to even use it. Why bother? Oops. Well, the code is not as pretty, but there it is. We can use a ternary operator too. Maybe let's see if we can make it prettier with a ternary operator. So this dot h equals, we'll go like this, h question mark, right? And then we put something here, and what is it, a colon, I think, right? And then you put something here. End of statement right there. So this is called the ternary operator. I mean, it has 2 symbols in it plus 3 ternary, so it's 3. So it has 3 operands. So this is a binary operator. It's 2 operands, left-hand side, right-hand side. This question mark with a colon, a ternary operand with 3. Ternary operator with 3 operands. This leftmost operand is checked for whether it evaluates a true or false. If it evaluates a true, then the expression evaluates to the second operand. If the first operand evaluates to false, then the expression evaluates to the third operand. Yeah, let's take a look at how we're going to do this. So if H evaluates to true, then we want to use H. Otherwise, we'll use 100. But this is the same problem as this. That's essentially the same as this here. This expression, because if we pass in 0 for H, that'll be evaluated to false, and then we're going to end up getting 100. So we could do something like this. We could say if H, we'll do this. H not equal to undefined. It's, once again, it's hard to read, right? So maybe to make it a little easier to read, you do this. And maybe you don't like ternary operators. Maybe ternary operators are hard to read. So, but this is how you would do it that way. So there's many ways of doing this. One thing I want to talk about as well, you might be curious, like I'm using a double equal sign here. You could also use a single equal sign there. And what's the difference between those two? I'll tell you the difference. I'll demonstrate the difference. It's hard to, if I just sit here and explain it, it's hard to get it. Okay. We'll use the console window, that's convenient. So, you know, is 1 equal to 1? Yeah, that's true. Is 1 equal to 2? No, that's false. Is 1 equal to the string 1? No, that's false, right? 1 is not the string 1. But is 1 double equal to the string 1? Ah, well, that's true. You see the difference? So the triple equal sign is means don't do any data type conversion. If the left-hand side and the right-hand side are different data types, the expression is false. It can't be equal. But if you use a double equal sign, then the JavaScript, the engine will try to coerce, will try to convert the two different values into the same data type and then compare them. So here, either 1 is converted to a string and compared with the string 1, or else the string 1 is converted to an integer 1 and then compared to the integer 1. I don't know which one it is. Okay. And I never had to figure that out. But this is a difference between double equal and triple equal. And also it's the same thing, you know, this is the not version of it. And this is the, you know, these are the two right here. Okay, well, let's do another example here. So we'll do 1 is not equal to 1, right? That's true. But 1 not equal to the string 1, oh, that's false. See, so it's, you do the same thing with not equal to as well. All right. So let's start over again here. We've got an application. We're trying to build a video game. We got this global application object A. We pull out the context, the 2D context from the canvas. All right. The other one, WebGL, that's for you're using low-level graphics. You know, WebGL is fantastic. It's like you can use shader code and use 3D, basically 3D graphics. You can do right in the browser. Use JavaScript. It's pretty fantastic, actually. And here we have the constructor function for a text object, and these are what I would call game objects. So we're going to, the text is a game object. The game object is something that you can put into the game loop, simulation loop. And the game objects are all, they have a draw method, or sometimes they have an update method and a draw method. The first update methods are called in all the game objects to let them all carry out their various AI programs, and then the draw methods to let them all draw themselves. And I'm not using an update method, I'm just doing everything in the draw method. So look at this. So the text that's going to represent a string that appears in the canvas. And so you'll need a draw method right here. And so we associate the draw method with instances of the text constructor function by adding a draw function to the prototype object of the constructor function. So when you create a function, and we looked at this in a previous session together, that whenever you create a function object, a field named prototype is created. And if you create an object that's not a function, then there's no prototype field created for that object. And this prototype field is used to define the prototype, which then becomes which is attached to the object that's created with that new operator. So whenever we create a text object, whenever we create an object using the text constructor, there'll be a draw function that we can call on it. And the draw function takes, I'm defining the draw function as taking an argument delta time. So that'll be, like 17 milliseconds, something like that, if it's a 60 FPS. And so in the draw method, we take the context object and set the fill style, set the font, and then call this fill text function here and so on. I'm going to get into those details. The box function is the same thing. We got the constructor, and it needs a draw function. There we go. This is how you draw the box, and it's this concept of a death, right? Remember, if the box gets hit by a missile, it's now labeled as dead, and then it has a different, you draw it differently. So if, I should probably explain this, this line right here, this line right there. So when a box object, when you call draw on a box object, this first line of code, this represents the object that the draw is being called against. And if it's another way to express this. I'm doing it the formal, clean way, but there's another. You could also do it like this. If this dot death is not undefined, right? In other words, if death is defined, if there's an attribute named death attached to the object, then then what do we do here? We just, oh yeah, I see. So if death is attached to the object, all we do is we take this death, the value stored in death, and we reduce it by the delta t, the number of seconds for this frame of animation. Otherwise, we change the y value of the object. That's why it goes down. By the way, see the positive y is in a downward direction. That's typical for 2D campuses, 2D game. Positive x goes to the right, like this. A positive y goes down like that. So we want the box to be falling. That's why we add. So we add. We're falling at a rate of 100 pixels per second. So we take 100, multiply it by the number of seconds for that frame. And so dt is going to be small. Usually dt is going to be something like dt is approximately equal to 0.017. That's at 60 frames a second. So that means we're going to run, what, 1.7 pixels. So that'll be rounded to, I don't know, 2, or maybe it'll be truncated to 1 when it's rendered. All right. So what about this? This is what would be considered, I mean, they both work. Here, this has own property. All objects in JavaScript have this function has own property. So every object in JavaScript has that defined. So here's an object has own property x, right? What the heck? Has own property. Expected token dot unexpected token. So this here we're creating. I think I need to put that in parentheses. We need to see because I'm constructing the object. So let's do it a little differently. I'll do that a little bit differently. Let's take our object, we'll call it O. I'll put it in the global namespace. Now we're going to create an object O. Right? And then O dot has own property. Can you read this, by the way? Maybe it's not too small for people back there, right? Is that okay? It's all right? And so that's false. And of course, if we take O, we could define an x, set it equal to 1, say, right? And now, I didn't do this right. Let me reset that. Sorry about that. Screwed that up. All right, hold on there. There we go. What the heck? I'm trying to get rid of these things. Clear the console. Reload. There we go. So I'm going to say O is set equal to this object. And we're going to go O dot has own property x. That's false. It doesn't have a property name x. But if we take O and attach a property, we can do that. And now O dot has own property x is true. So if you want to know whether an object has a particular property or not, you can use this has own property. You could also do it like this. You could say O dot x, right? Is that undefined? That's false. What about O dot y? Is that undefined? Well, that's true. So that's another way to do it. Well, why doesn't it just say has property x? Why does it say has own property? What's going on there? let me clear this again here. Get this. There we go. It has to do with the, look at this. Let's create this O again. Well, here's another way to create O, by the way. O is, you could have the property X, right, set to the value 3. We could do that, all right? Now, O dot X, undefined, that's false, right? So it's there, right? O dot X is there, O dot X is there, it's defined, it's 3. Let's have another function or another object P, and we'll start with an empty object like this. Now P has a prototype. Let me see if I can do this. Is that a double underscore? I can't remember now. Oh, no, proto, that's what it is. I think it's a double underscore. This is huge, it's giant. That's the pointer to the prototype object. Can I modify the prototype object? I don't know if I could do this. Oh, it lets it happen. Okay. So P dot X. See, P dot X is 3. O dot X is 3. So now P dot X is 3 because its prototype has a field name 3. So it inherits from its prototype. But whereas O dot has own property X is true, right? But P has own property X is false. So has own property means is the property not inherited through the prototype chain. So that's what has own property does. Any comments on that or discussion? Good. Yeah. So, in this code, it doesn't matter. You could do it this way, you could do it this way. It just doesn't matter. It has to do with, I don't know, what's easier, what's more readable for you. And of course, there are hidden, sometimes bugs pop out. Here, what if death is being inherited through the prototype chain? Then this code will fail. And so I was using this expression because I wanted to make sure, just in case, there was a field named death, that was somehow in a prototype, one of the prototypes, because you have a prototype chain, right? The system, if I say P dot X, and the system looks in P, is there an X in P? And he goes, oh no, there's no X in P. Well, is there an X in its prototype? No, there's no X in its prototype. Well, is there an X in the prototype's prototype? No, there's not one there. Well, is the X in the prototype's prototype's prototype? So it goes up the chain until it hits a terminal prototype. But all objects terminate with the same top level prototype, by the way. And that top level prototype, by the way, has the function that has own property. That's where has own property comes from. It comes from the sort of the terminal or parent or grandparent, whatever you want to call it, the ancestor prototype, the root prototype. Maybe that's the best way to call it. Anyway, here's the formal way to do it right there. And, well, not formal, but maybe safer. So this is that logic. So if this box object has a death attribute set to it, then it has kind of like a timing has a timeout to it. It's like, how long are you going to sit there on the screen? The number of seconds to sit on the screen is stored in depth, and so we reduce it by dt for each iteration of the loop. And then at the end here, look at this. So, well, so when death reaches 0 or goes to negative, it'll be taken out of the game loop. And that's done somewhere else. It's not done here. I think it's done in the game loop. Let's see where that would be. Here it is. Here's the loop. And this is where you calculate dt, delta time. And there it is right there. So this is where we check to see if O has a death property, and if it's positive, then it's good. Right? So in order for the object to continue on in the game loop, it needs to not have the death property, or its death property must be positive, which means it has remaining time left to be visible. And I should probably explain this filter. I'm using this. This filter function is all arrays. All arrays that you create have a prototype that has the filter function in it. So every array that you make, an array is an object. An array is an object, and just like a function is an object. When you create a function, when you define a function, it has that prototype field, right? Well, when you create an array, it has a prototype that has a whole bunch of functions in it that are just useful for arrays. And one of them is called filter. And that's what I'm using right here. So we can talk about that. This is a very useful and important function, as well as the other array functions that you look at, like for each. For each is extremely useful. What filter does, yeah, it's kind of, what filter does, let's take a look at filter. I wonder if clear works here. No, it doesn't do anything. Why is that there? If I create an object O, right, and I do O.filter, it's undefined. But if I create an array A, that's going to collide with my application object. So let me do P. If I create an array P, right? That's an object, just like O is. But P, if I do P.filter, it's not undefined. You see, when you create an array, that array object has a prototype with the filter function in it. And let's look at what it does. So we go P dot. Let's add some values to P. Let's push a 1. Let's push a 2, and push a 3. So if we render P, it does it like that. It's nice. Just when I type in P on the console window, it tells me it has 3 elements in it, and that's 1, 2, and 3. And let's create a new array. If I take P and dot filter, now filter takes a function. Right? filter takes a function, and what it does is it iterates through the array and calls the function for each item in the array. It constructs a new array based on the whether the filter returns true or false. In other words, let's suppose you want to shrink the array. If you want to remove things from the array, filter will remove things. If the function returns false, it means don't include that item in the new array. So I'll show you what I mean. So the function is going to, it takes an item, say I. As it goes to the array, the function is passed in item one after another. So the functions can be invoked with 1, that's going to be invoked with 2, that's going to be invoked with 3. And if we just return true, right? We return true. Whoops, sorry about that. I'm going to close that off. Then it produces the same array. But if we return false, we're telling it to omit each item from the new array. But we could use, let's suppose we just want to remove 2 from the array. So we return the I is the item value, not equal to 2. So any item that's not equal to 2, include that in the new array. You see how that works? There's the new array, 1, 3. So that's the filter function. And there's another nice function that's even more common to be used. It's called for each. And that also takes a function. Wait a minute, is for each, is it lowercase? Yeah. And that also takes a function at each item. And it'll do something with that item. So I'll do something like, I equals, I don't know, we'll do something like plus I. Let's increment the value in I. And undefined, it means the expression evaluates undefined, which is okay. So print P now. So something is wrong there. So it must be I equals, is this right? Is this going to work? Does this even work? This is, you know what, this is, I've got to think about this one. Hold on there. Let's do something like this. I'll do I plus 2. Now that plus I is some, I don't want to dig into that right now. I knew I was going to have a problem with that, and I should have stopped, but anyway, here it is. So what for each does, we pass the function into for each. It'll iterate through the array and call your function, passing each item into the function. And what the function does here, I'm just printing I plus 2. So there we got, 3, 4, 5. That's 1, 2, and 3. Each value plus 2. And then look at the word undefined here. Do you see what's going on? Why does it print undefined? Because it does what the function does. It carries out the function. It executes the function, which is to print to the console 3 times, 1, 2, 3. And then afterwards, this console then shows you what the expression evaluates to. So you see the expression P dot for each, etc. That expression evaluates to something, but it actually evaluates to undefined, and so it prints it there. It's just like when I type in P, what am I going to say? Up here, when I do P dot filter, right? me show a better one here. This one right there. This p.filter, it doesn't do any printing, but after it runs, the console prints what this statement evaluates to, which, and this, see, filter returns a value. Filter returns a new array. And so the new array is then printed in the console, because that's what this statement evaluates to. But here, for each does not return anything. It's void. You call it a void function. And so when the console goes to print, when it goes to display what the statement evaluates to, it just shows undefined because it's a void function. It doesn't return anything. Is this useful? I'm just like going on and on about the language. You know, these are the kind of things that, you know, when you study JavaScript, you gotta, I mean, for me, to master a language or master anything, you're gonna play with it. And like, I'm just playing with it. The stuff that I'm doing now, that I'm experimenting with and illustrating here, this is how I learn a new language. This is how I learn new APIs, how I learn anything new. Well, and I have to experiment with it. I have to tinker with it. I have to push this button and see what happens over there. I mean, sometimes it's dangerous to push a button, so you don't always do that, right? Like when you're learning how to build a bridge, although maybe you can build a prototype first. You know, I'm showing you just sort of like this process of how to tinker and experiment on your own, because that's how you're really going to learn and master this stuff. Not sitting in my lecture forever. Right? Maybe you'll learn a little bit, and when you've had enough, you say, "Oh, I know how to do that. I'll just do that by myself if that's what I need to do." So I think maybe that's enough for today. Is there any comment, any discussion you want to? No, it's good. Good enough. All right, that's it then.